Hey guys, welcome to today's lesson. We're looking at some HSC integration questions. I've tried to choose a range of questions for the work that we've done so far through this unit. It's not a bad way for us to finish off. It's a good idea for you to pause it, have a go at some of these questions, and then you can follow through some of the instructions. Okay, so the first question, question B, you don't get these ones too often, I will be honest with you. These are pretty straightforward. So if you do manage to get these ones in the HSC, you're quite lucky. So the first one is simply 5dx, where we are doing some basic integration. Now, noticing that this is going to be an indefinite integral. And it's indefinite because we have no intervals there. Okay, no x values. So in this case, we're just going to be doing 5x plus c. Okay, that's it. Nothing else we can do. That is my final answer. Hence why it's only worth 1 mark. Okay, the next question, which is a bit more challenging, is the integral of 3 over x minus 6 all squared dx. Now, we haven't done any sort of logs at all with integration or differentiation, so this can't be a log, but certainly when you have done the logs of integration, that's the first thing that we should look for. But in this case, it's going to be just a normal integration question. So what I'm going to do, I'm going to rewrite that question. I'm going to rewrite it and put it in indice form. So x minus 6 to the power of negative 2 dx. That's the best way to solve this. Again, it is an indefinite integral, so we're going to be having that plus c on our answer. Okay, so let's go now. This is going to be a chain rule question as well. That's always a good one to practice for our chain rules. So, my chain rule says I'm simply going to add 1 to my power. That makes it negative 1. And I'll put it over negative 1. And then we always times it by the derivative of the brackets, which in this case is just 1. So we get 3 outside of x minus 6 to the power of negative 1 all over negative 1. Okay, which I could actually just, if I wanted to, put that in front of it. Okay, now with any of these questions, very important, if it came in the, process of being a fraction in the question, let's make sure we do that for the answer. So equals negative 3 over x minus 6, and then make sure you don't forget your plus c's on the end as well. Okay, alright, nearly at the end there of that first question. So number 3, now this is coming to be a definite integral. Can you tell why? Hopefully you've noticed that we have values for x there, or our intervals. So we've got 4 and 1 as our intervals. We have x squared plus x to the power of a half dx. Hopefully you recognize that x to the power of a half was the root x. We always want to deal with indices as opposed to absurds. Okay, from there, we're now going to integrate. Remembering I'm going to put square brackets because I'm going to be doing a substitution method with a 4 and a 1. So I'm having x3 over 3 plus x to the power of 3 over 2, because I'm adding 1 to a half, over 3 over 2, putting 4 and 1. Some people might write this as 2x over 3 because you can flip it. But when I'm doing my values, because I'm going to be using a calculator, I'll just leave it as it is. Okay, so now we want to then substitute into it and make it 4 cubed over 3 plus 4 to the power of 3 over 2 over 3 over 2. That's my first one. Minus, put in my second one now, 1 to the power of 3 over 3 plus 1 to the power of 3 over 2 over 3 over 2. And I now simply put this into my calculator. Now you'll notice that when I did my working, because by other lessons I actually do these like 4 to the power of 3 in my head. These case, in an exam, just substitute, always substitute, so you can show the marker what you have done, where that number came from. They can clearly see that came from putting the 4 into it. If you want to put the 4 in brackets each time, you certainly can do that as well. That's even a bigger indicator of where those values have come from. Okay, so get your calculator out, put it in, and see what you come up with. Okay, so hopefully you came up with 80 over 3, and then subtract 1. If you do that, you then come up with 77 over 3. 77 over 3 units and its area, so it's units squared. If you want to put it as 25 2/3, you can certainly do that as well. That's obviously still correct. Okay, so a fairly straightforward question. It's worth 3 marks. It's not a bad, that's not a bad HSC question if you can get that. Yeah, as I said before, you'll be very lucky. Okay, so that's the first one. Next question. Let's go and have a look what I have in store for you. Okay, have a pause, see if you can come up with it. This is a Simpsons Rule question. Hopefully you remember the formula. Okay, welcome back. So hopefully you recognize that the formula for my Simpsons Rule is, oops, my apologies, is h over, now it's not 2, that would be your trapezoidal rule. It's h over 3 times the function of the first plus function of the last plus 4 times the function of the odds plus 2 times the function of the evens, and go from there. Do note, and I apologise, I should have put this there, that was supposed to be 200. Okay, it didn't come out before. Okay, so if you haven't taken that as 200, just make sure the working out's correct. So first things first, your h value. Now, remembering your h value can come from b minus a over n, where b and a is how many intervals you've got, all that sort of stuff. Now, to be honest with you, I don't really look at it that way. I just look at what the height is. What's that constant height across? And we're told that constant interval is 50. So we're going to have 50 over 3 times. Now, sometimes you might have x values in y values in a table. Okay, you can put them all on a table if you want to do that, but to be honest with you, that's pretty much in the table for me as it is. So I know that my function of the first is 210, my function of the last is 240, 4 times the functions of the odds. Now my odds will come from 1, 3, and 5. Okay, so 220 plus 190 plus 240. And then my evens will come from the 200 and the 210. So plus 2 times my 200 and plus 210. And then it's a matter of putting that into your calculator. So if I do that, we get 64,500 meters squared. And that's an approximate area. That's why I've used approximately equal to. Okay, so Simpsons Rule. Just make sure you remember the Simpsons Rule and the trapezoidal rule. Trapezoidal rule is similar to that, but it's h over 2 times the function of the first plus function of the last plus 2 times the functions of the rest of them. I'll put f rest. But no, certainly that's the trapezoidal rule. So just make sure you know the trap rule and you know the Simpsons Rule. Okay, next question. This is an area question, obviously, for integration. This is where we have 2 different graphs going on. So most likely, in terms of the lessons that I've shown you, think about the sum and difference of areas. Okay, that's where we're going to be going with this question. So the diagram shows the parabolas of y equals 5x minus x squared and y equals x squared minus 3x. The parabolas intersect at the origin O. Okay, that's great. We've got a point of intersection there. It says we have also another point of intersection at A. Now, I don't have that, and I'm going to guess that's what they're going to ask me to find, because I'm going to need to know what that is to find out my areas. The region between the 2 parabolas is shaded. Find the x-coordinate of point A. There you go. So for point A, what we are wanting to do is, for any points of an intersection, simultaneous equations. We know that y equals 5x squared, 5x minus x squared. We know that y is equal to x squared minus 3x. So if I solve it simultaneously, that means we're going to substitute this case, put y x squared minus 3x for where the y is. So we get x squared minus 3x equals 5x minus x squared. Let's put everything to the one side. I'm probably going to do the left hand side because it makes the x squared positive. So I'm going to add on x squared here to get 2x squared. I'm going to take 5x across to make minus 8x equals 0. I'm going to factorize to make it 2x outside of x minus 4. and I'll now have my values of x equals 0, which I already know that one, and x equals 4. Therefore, A has x equals 4. Okay, you can from the y coordinate if you wish to by substituting back in, but in this case we don't really need to know it. Okay, so that's part 1. Part 2, which is where 3 marks are coming from, is going to be the majority of your question. So, how do we do this? Well, what we can do, we've got our 2 regions here, our intervals. Well, we can find the area underneath that first curve, y equals 5x minus x squared. As such, we can do that. That's no dramas at all. We can do that by saying the integral between 4 and 0 and y is 5x minus x squared dx. So we can do that. That's no dramas at all. We can also find the area underneath the curve y equals x squared minus 3x, which is this part here. We know how to do that. We can do that by doing the integral between 4 and 0, and then that's x squared minus 3x. A bit hard to see there in red, so my apologies. We can set it as well. So how does that help us to find out this area on the inside? Well, if I subtract them, okay, it's going to leave me with that area above it. So I can certainly do that. Now you can write these as 2 different integrals and 2 different areas. Some people actually like to do this. They like to actually write it as 5x minus x squared minus x squared minus 3x dx. The issue is there you need to make sure it's be minus x squared and then plus 3x and do it from there. I find people forget how to do that, and they don't realize that. So they do 5x plus 3x is 8x, and then minus 2x squared dx. Okay, but if you can do that, that's no dramas. That's quite a quick way to do things. But certainly, one of the ways not to make a mistake is to do them separately. In this case, it's going to be 5x squared over 2 minus x cubed over 3. With 4 and 0 minus, and then the next one's going to be x cubed over 3 minus 3x squared over 2. That's also 4 and 0, and then we can simply substitute our coordinates or x values into it. So we get 5 times 4 squared over 2 minus 4 cubed over 3 minus 4 cubed over 3 minus 3 times 4 squared over 2, and then simply put that into the calculator to get the following. So it's going to be 64 over 3 units squared. Now, there's a couple of things before I move on. A couple of people are a bit worried about this question and get a little bit confused because they say, hold on, this part underneath the y equals x squared minus 3x is going to be a negative area because it's negative definites underneath the x-axis. The problem is I get to this point and then I get above. Shouldn't I be worrying about absolute values and adding things and that sort of stuff? And we get quite, distressed by that. So all I'm going to say, it's very basic, but what we can have is if I redrew this as my parabola a little bit higher up and a little bit higher up there, if I do that parabola, which is the same parabola, okay, that's still going to have the same points there for 1 and etc. But if I look at that area there, that area would be exactly the same area as what's bound by those 2 curves. Okay, obviously if I drew that to proportion, but certainly that's the same area. So I can just assume that I can take this whole thing, put it all the way above the x-axis, and it's all good. I don't have to worry about what's above and what's below. Just chuck it all above and it works. Okay, it's the same area, it's the same amount, so it would work either way. The other thing is, I've shown you how to do this, and I usually do it as two different integrals. Would this work if you use this integral? And the answer is absolutely yes, it would. If I integrated that, we'd make it 5x squared over 2 minus 2x cubed over 3 with 4 and 0. If you substitute 4 and 0 into those things, you're going to get the same answer. Except for one little issue, and lucky I'll pick that up quickly. That was an 8. Make sure you don't do what I do, make sure everything's really neat. But you substitute that through, that's going to be exactly the same answer, 64 over 3. You might find that a little bit quicker, but it's up to you. Okay, so that was a fairly, I don't think it was a very tough question, but certainly, it wasn't particularly easy. Okay, and the very last question we're going to look at. Now, of course, the last thing we did was volume, so this is the last question that we're going to look at as well, which is volume as well. So, the shaded region in the diagram is bounded by the curve y equals x squared plus 1, the x-axis, the lines x equals 0 and x equals 1. Okay, so one of the most important parts here is going to be this thing, which relates to this thing. Okay, or should I say this thing? So it is rotated about the x-axis. Why is that important? Well, that's important because we know the formula is pi times the integral, and if it's bounded around the x-axis, that means it's going to be dx. It means it's going to be y squared dx. All right, because it's differentiated of the x-axis. That's the way I think about it anyway, and it works. So that's the formula that we need to use. What are our regions, or what are our x values, or what are going to be our amounts there? So we go to 1 and 0. It says that on the graph. We can see 1, we can see 0. We've got a function which is y equals x squared plus 1. That's probably the only issue. I know this is a question 9. It's not a particularly hard question 9, but you might be thinking something must be going on here because it's going to be a little bit different, and that's probably going to be where it's going to hit you. We need to have what y squared is equal to. Okay, so we need to square these things. So we can have x squared plus 1 all squared. Now, sometimes we can leave it and we can use this as the chain method. The only issue if you did the chain method when you did your integration, okay, if we integrated this, let's have a quick look at it. We'd have x squared plus 1 to the power of 3 over 3 times, and then I have to differentiate this, which make it 2x. And the issue with that was going to be, it's not really much of an issue, is it? It's really there. We're going to have x squared plus 1 cubed all over 6x. Okay, actually there's no issue there. We can do it that way there. So that's actually quite nice. This means I'm substituting into it a couple of times. The other thing you could do if you wish to do the expanding method, so square the first, square the second and double it, so times them together and double it, and square the last, and then you can you integrate from there, make it x5 over 5 plus 2x3 over 3 plus x, and believe it or not, they might look different, but they will give you the same answer. Okay, so you can integrate whichever way you would like to integrate. That is up to you. It's going to give the same answer no matter what. I might choose this way. How's that? Okay, so we have got our values. So let's put this in. So over here we've got 1 first of all. So 1 squared plus 1, and then I'm cubing it all over 6 times 1, and then I've got 0 squared plus 1, cubing it all over, that is a problemo, isn't it? So that's not going to work, because when I substitute the 0 in, we can't divide by 0. So you know what? My apologies, we can't use a chain rule. That might happen in an exam. If that happens in the exam, then obviously think there's got to be a second way of doing it. So we're going to look at this. I'm actually glad that worked out, because then we can see when that does happen. So I'm going to do this one now. So we'll try this one. So 1 to the power of 5 over 5 plus 2 times 1 cubed over 3 plus 1. Subtract. and then do it to 0. 0 to the power of 5 over 5 plus 2 times 0 to the power of 3 over 3 plus 0. And what you'll notice with that, 0, that's 0 and that's 0, so that all cancels out. So I'm actually going to be left with just this one calculation on the left-hand side. So it's going to be 1/5 plus 2/3 plus 1, which I'm left with. Now remember, we've got the pi at the front as well. 28 pi over 15 units cubed. Okay, and it is important to make sure, because I didn't put that the first time, we need to make sure we have our pi at the front. Don't forget about that, because certainly that's where marks get deducted. So sometimes some ways won't work, and you can see that was a great example of something that didn't pan out. It might not mean you've done it the wrong way. It might just mean that way is not possible. So always look for different options. If one way doesn't work, look at it a different way and see, how can I do this differently? We could see that there are two different ways in order to integrate that question. So one way didn't work. I tried the second way, and fancy that it worked out. Look, different types of questions, guys. There are huge amounts of questions in the HSCs about this sort of stuff. This is often where the hard questions come from. I will say that I haven't touched upon anything to do with logs, trigonometry, or exponentials. There are a lot of questions in the exam papers at the moment to do with those types of integrations. Obviously, we're not there yet. So if you do see those and you start freaking out because you can't do it, that's normal. We're doing that for the next unit after integration. Okay? Hope this is helpful. Keep on doing your examinations. Let me know if there are any problems.